Hola, my geometry friends. This is a little snapshot back in time. At one couple of years ago, Penfield High School was voted one of the most spirited schools in the county. So before school, we had the news channel come. I don't remember if it was 10, 8, or 13, but they came and recorded a live video feed, live news feed that featured our robotics team right here in the top right-hand corner. Our sports teams and doing cheers and yelling and screaming for the cameras. And our music program right here. You can see my wife in the background on crutches when she broke her ankle. And then, of course, Penfield's favorite teachers in the band No Child Left Behind, with Mr. Gaby here in the background, Mr. King, who sings and plays guitar, Mr. Gaby plays guitar, myself on drums, and Mr. Graves, who plays bass. So that was a wonderful thing that happened, and I just wasted a minute of your life explaining it. Now on to geometry. Okay, we're almost done with all the new rules for this unit, and then we're going to get into proofs coming up here soon, but we got to do some more calculations today. So our first rule, our first theorem, the product of the partial segment lengths of intersecting chords is equal for each chord. So what I mean by the product of the partial lengths, if you look at the diagram, the partial lengths would be the parts of the chords. So we have partial length labeled C, and the other partial length is D. So if we multiply those two parts together, it will equal the parts of the chords A times B. So A times B equals C times D. Now we will do a proof of this later when we start into our proofs, but for now, just accept that if you have two chords that intersect, you can find their lengths by equaling the product of their parts. Next, we got some more figuring to do with our tangents and secant segments. All right, so here we have the product of the partial or outside parts of the segment is equal to the whole segment. So you do the product of the outside parts equal to the whole segment. That's equal for each secant. So let me explain and show you a little bit more detail what I'm talking about here. So the product, it's outer piece times the whole thing. So the outer piece is the W. That's the outer piece. That's the partial part. And then the whole length would be W plus X. So you got the outer piece times the whole secant is equal to the outer piece times the whole secant on the other side. So that works as long as these two secants come from the same point. Two secants that come from the same point, their outer piece times the whole secant. And the whole secant means from the outside point where the two secants touch to the other far side of the circle. If for some reason the secant was drawn further, we don't care about that. We're going to stop where it hits the circle on the other side. All right, so anything that goes beyond that doesn't matter anymore. We're going to stop when the secant goes from the point of intersection of the two different secants and stops when it hits the far opposite side of the circle. But it's the outside piece times the whole thing equals the outer piece times the whole. All right. Third one follows the exact same rule, but instead of two secants, one of them is a tangent. So it would be outside piece times the whole length equals outside piece times the whole length. But because one of them is tangent, the outside piece just happens to be the same as the whole length. So if we did outside piece times whole length, like the rule we just talked about, the outside piece being t and the whole length being t again would lead to the square of the tangent, so t squared. So if it's a tangent in a secant, the outside piece is the whole length, but it would be the square of the tangent line equals outside part times whole. So it would still be the outside part of y times the entire secant from point P to the far side of the circle. Again, if this was extended further, that part wouldn't matter. Same thing with my tangent line. If my tangent line is drawn further, that extra part doesn't matter. Once it goes beyond the far side of the circle, we don't care about those lengths anymore. All right, so tangent squared equals part times whole, the outside piece times the whole secant. Now, what about the case where it's two tangents? Well, if it's two tangents and we follow the same rules, then what we should be doing is outside part times whole, outside part times whole length, which happens to be the same thing, and then outside part times whole length, which again happens to be the same thing. That means the two tangents are congruent. So that means segment or tangent AB is congruent to tangent AC. That's if they come from the same point. Okay? Tangents that are drawn from the same external point are congruent. The calculation would be outside piece times whole length. So that'd be x squared equals y squared. So x equals y, same length. So let's do some calculations. We are going to use those rules and our calculators and our brains and do some calculations, and then you're going to be off on your own to practice. So we're going to find the value of x. This is the first rule that we talked about today. When two chords intersect, it is the product of their parts are equal. That means 4.8 times x equals 7 times 7. And then once you have that written down, you go to your calculator, plug them in, and write down your answer. So you do 7 times 7 divided by 4.8. So that means you have 49 divided by 4.8. And what we're supposed to do, if they do not tell us how to round our answer, you can just write everything down, but the expectation is to keep only 4 decimal places. So I would look at the 5th decimal place to determine whether the 4th one should round up or not. So this would be 10.2083. If the rounding is not written in the directions, you can either leave it exact as the fraction 49 over 4.8 or carry 4 decimal places. That's the AP equivalent, or that's the expectations when you take the AP exam. If you end up taking an AP exam, they just expect everybody to keep 4 decimal places. So that's what we tell our students in our pre-AP courses. Okay, so do the same thing, solve for y. If you need to pause, that's fine, because I'm going to do it right now. So it's 5 times y equals 4 times 9. We end up with 36 divided by 5. So we can write it as 36/5 or the decimal 7.2. All right. Now let's use the other rules. So what do we do next? We're looking for the value of x. If you think you know what you're doing, pause the video, do the calculations, and turn it back on, and I'll go through it. If you feel like you need me to guide you through it, then stay with me. Here we go. So the rule was it's the outside piece of 14 times the whole length of 14 plus 24. That's one side of my equal sign. The other side is outside piece times full length. So it's going to look like 14, that's the outside piece, is outside the parentheses. 16 is the outside piece, is outside the parentheses. Inside the parentheses, we add the full length of 20 plus 14 and the full length of x plus 16. So the 14 and the 20, we can just go ahead and add those together and make it 34, and then do 34 times 14. On the other side, we're going to have to distribute the 16, so it's 16 times x and then 16 times 16. At this point, we just need to get all the numbers to one side and all the x's on the other side, and then we'll just write down our answer. So you do 476 minus 256, and then you're going to divide by 16, and 220 divided by 16 is 13.75. So let's see what happens with this one. This is a similar kind of rule, except for instead of outside times hole equals outside times hole, we have the tangent. So it's tangent squared equals outside times hole. The outside piece of 8 goes outside the parentheses. Then we add the 8 plus the 16 to get the full length of that secant. And once we have that, boom, we have an answer of 8 radical 3. Okay, so why don't you go ahead and pause the video and try example 5, solve for y. This one ends up a quadratic. Let's see if you can factor and solve. So our equation's outside piece times hole, outside piece times hole. So the outside part of the secant is outside the parentheses. The outside part of the secant, the y value here, is the outside part of the parentheses. So 6 plus 8 is 14. Distribute the y. We need it equal to 0, and then it'll factor. And because this whole calculation came from segment lengths in a diagram, we have to reject anything that's a negative number. Negative numbers do not work as lengths. So if we end up with a negative length, we will reject it. If you end up with a negative length, you will reject it. And then just keep the positive value of 7. Yay, y is 7. Last one that I'm going to do with you together, and then the rest is on your own. We are going to try to figure out how to find A and B. So which one should we do first? Well, if we can figure out how to find A, then I can figure out how to find B afterwards. So what I'm going to do is I am going to, let me get a highlighter, that'll help. I'm going to use the tangent squared equals the outside piece times the whole secant segment. And when I use tangent squared equals outside times whole, my whole length from one end all the way to the other is going to be 8 plus A plus a second A, 8 plus 2A. From external point to far side of the circle, it's 8 plus 2A. So go ahead, distribute and solve. All right, here I come. So if you're not ready, pause it. There we go. So A is 5. Now that we know A is 5, we can do 4 times B equals A times A, and then solve for B. So it's 4B equals A squared. A is 5, so 4B equals 25. 25 divided by 4, 6.25. All right, so I flew through that. Hopefully you're okay. Remember, you're supposed to pause it if I'm going too fast. And good luck to you because you're doing some more practice now. Tomorrow is just a full day of practice, and then we start proofs. Okay, so good luck. Be well to each other. Be well to yourself, and I'll see you soon. Thank you, and goodbye.